Welcome back. In the previous session, we have discussed about the general properties and chemical properties of acids and bases. How acids and bases react with variety of different substances like metals, metal carbonates, metal oxides and non-metal oxides. So at the end, we realized that when acids and bases react with each other, they produce salts, and also in some other reactions, formation of salt is seen. In today's session, we will be discussing about salts. What are the different types of salts? How exactly are they formed? And what are the uses of these salts in everyday life and in industry? So let us get started. Now let me write down a couple of names of compounds that you are aware of, and we will continue the discussion from there. So sodium sulfate, sodium chloride, potassium nitrate KNO3, aluminium chloride, copper sulfate, zinc sulfate, sodium carbonate and sodium hydrogen carbonate. Now, these are all examples for salts. If you look at them carefully, we can classify these salts into different families of salts. So it is a very simple activity. Take for example, the first example, sodium sulfate, Na2SO4. First we have to identify which is the cation and which is the anion. It is very straightforward. The cation in this case is sodium Na plus, and the sulfate will be the anion, that is SO4 2 minus. Similarly, if we do this for all these salts here, sodium chloride, potassium nitrate, let us take aluminium chloride, AlCl3. So here the cation will be aluminium, that is Al3 plus, and the chloride ion will be the anion. So when we compare the cations and anions among these salts, we can group them together into families. So with that activity, we can group sodium sulfate, sodium chloride and sodium carbonate and sodium bicarbonate into one family, that is the sodium family of salts, because all of them have the sodium ion as the common cation. So that is the sodium family of salts. Similarly, we can also group sodium chloride and aluminium chloride in one family, that is a chloride family, wherein the anion is common, that is chloride. So that is a chloride family of salts. Similarly, we can also group sodium sulfate, copper sulfate and zinc sulfate. Here the sulfate ion is common among all these salts. So that is the sulfate family of salts. So that way we can group the salts based on their cations and anions. Now it's a very simple topic. The next question is, how are these salts formed? So that is a very important concept that we are going to study. Take for example sodium chloride, that is our common salt that we use in kitchen for cooking. How is this salt produced? In general, a salt is produced from a reaction between an acid and a base, as you have already studied in your previous class. Acid plus base will give you salt and water. So that is how in general salts are formed, either in nature or in industries through chemical processes. So every salt is made up of an acidic portion and a basic portion. Let us understand this. So in this case our salt is sodium chloride, that is the salt. So it requires an acid and a base. So in this case the acid produces the chloride part. If you think of acids that have chlorine in them, the acid that comes to your mind is hydrochloric acid, HCl. So we can identify the acid that makes up sodium chloride. Similarly, if you look at this part, Na, so this sodium should have come from a base. Bases, you know, they produce hydroxide ions, so it will definitely have a hydroxide group in it, and it should also contain sodium. So the base will be NaOH. Now you know how our common salt is prepared. So hydrochloric acid combines with the base, and you know it is an example for a neutralization reaction, because the pH of sodium chloride is 7, that is neutral, and water is produced. Now in this example the pH of the salt is neutral. So this happens, a neutral salt is produced when a strong acid reacts with the strong base. All salts will have their own unique pH. It depends on what is the nature of the acid and the base. So in this example, hydrochloric acid is a strong acid, and equally sodium hydroxide is also a strong base. So when a strong acid and a strong base react chemically, we get a neutral salt. That is point number 1. Look at sodium sulfate. So if you have to carry this discussion forward, the salt in question is sodium sulfate, Na2SO4. Now we have to find out which acid and which base, which is the parent acid and which is the parent base that produces sodium sulfate. So of course the sodium part, as you can see, will come from sodium hydroxide, but here the anionic group is sulfate. So we need an acid that contains sulfate. So hydrochloric acid is a chloride acid, so that is not possible. Sulfuric acid, H2SO4. H2SO4. So we can see very clearly that when these two combine, we get sodium sulfate and water is produced. So in this case also we find that because sulfuric acid is a strong acid and sodium hydroxide is a strong base, the pH of sodium sulfate will also be neutral. Its pH will be 7, which will be shown as a very pale green color on the universal pH paper. So that is how we can theoretically predict the pH of a given salt. Practically, we need to take this salt, dissolve it in water and check it with the help of pH paper. Of course, their pH will match the theoretical findings. So they will be very close. So sodium chloride and sodium sulfate are neutral salts. That is what we have understood because they are formed from a strong acid and a strong base. Similarly, other than neutral salts, we also have acidic salts and basic salts. So, acidic salt is formed when a strong acid reacts with a weak base. Because acid is strong, the salt so produced will have acidic nature and you get water. And if you want a basic salt, then we need to take a weak acid and a strong base. So that will result in a basic salt. Salt whose pH is above 7 and we get water. So now you know how are different salts produced. So reaction between an acid and a base. If both are strong acid and strong base, we get a neutral salt. pH will be 7. If the acid is strong and base is weak, we get acidic salt. pH will be less than 7. Take example. So in this case we need a strong acid. So take the case of copper sulfate. So copper sulfate, there is a sulfate part which could have come from sulfuric acid H2SO4 and the copper part would come from the base. So base needs to have a hydroxide part. So copper hydroxide, so CuOH twice, and when these two combine we get copper sulfate plus water. So it's a very simple concept. By looking at the salt, you have to predict what is the acid and what is the base. In this case, if you make a copper sulfate solution and check with pH, it will have a pH less than 7 because it is acidic salt, because the acid is strong and the base is weak. If you are to give an example for a basic salt, we need a strong base. Strong base is sodium hydroxide, potassium hydroxide, which are alkalis, and we need a weak acid. One of the best examples for weak acid is acetic acid or ethanoic acid, which has the formula CH3COOH, about which you will study in the lesson carbon compounds. So it is scientifically called ethanoic acid, common name acetic acid, that is used in your vinegar. It is a weak acid. So when ethanoic acid or acetic acid combines with a strong base, what happens? We get CH3COONA plus H2O. You can see this part, hydrogen and hydroxide will combine to give you water, and the sodium will come and join here. Because in this case the base is very strong and the acetic acid is a weak acid, this will have pH more than 7. So that is sodium acetate or sodium ethanoate. That is a basic salt. Like this we can figure out the acids and bases of various salts. Let us quickly do that. In the case of potassium nitrate, the base is potassium hydroxide, which is a strong base, and nitrate will come from nitric acid, which is also a strong acid. So we know that a strong acid and a strong base will give you a neutral salt. So potassium hydroxide, nitric acid are the parent bases and parent acids. Take the case of aluminium chloride. The aluminium portion comes from aluminium hydroxide, which is a weak base, whereas the chlorine part comes from hydrochloric acid. So it is a strong acid, weak base. So it will be a acidic salt because acid is strong. Copper sulfate we already know it is a acidic salt. Zinc sulfate will also be acidic salt because zinc hydroxide will react with sulfuric acid. Zinc hydroxide is a weak base, whereas sulfuric acid is a strong acid. So that would also be, in theory, a acidic salt. Then we have sodium carbonate. Sodium carbonate is also an example for basic salt because sodium hydroxide is a strong acid, and a carbonate. The carbonate, it comes from carbonic acid, H2CO3, which is a weak acid. Another example for weak acid is carbonic acid, H2CO3. So you will get a basic salt, and in this case also sodium bicarbonate, which is a constituent of your baking powder, that is also a base. So we have successfully completed this activity of figuring out the parent acid and base of the given salts, and by doing so we have also predicted their pH. So we can classify the salts as neutral salts, acidic salts and basic salts. So that is another type of grouping. Other than grouping based on the cation and the anionic group, salts can also be classified depending on their pH. Acidic salts have pH less than 7. They are formed due to a combination of strong acid and weak base. Neutral salt has pH 7. They are made up of strong acid and strong base, whereas a basic salt is made up of a weak acid and a strong base having a pH above 7. But if you want these salts prepared in the laboratory, we cannot use this particular procedure mostly because it would be a very expensive process, and the chemical or the salt so formed will be very expensive because expensive chemicals are involved. So we need to find a compound that is abundantly available and relatively very cheap, from which we can produce other salts either directly or indirectly, so that we can produce more amount of salt as well as the salt produced will be less expensive. We have one salt among us which is very abundant in nature, from which all the other industrial salts are produced. That salt is the abundantly available sodium chloride. It is found in seas and oceans. Using sodium chloride industrially other salts are produced, and that is what we will see how we can use sodium chloride to produce other salts. This sodium chloride, as you know, it is mixed with water, so it is sodium chloride aqueous. It's in the solution form. We call this aqueous sodium chloride solution as brine, that is salt water is brine. So it's an aqueous solution of sodium chloride which is used to produce other salts. Let us see how.